Hey guys, welcome back to General Chemistry. Today we're going to continue our discussion of hybrid orbitals. So just as a reminder of what we were talking about. So hybrid orbitals are going to be orbitals that are in an atom, and they're not necessarily the standard orbitals. They're going to be a mix of S's and P's and so on. The hybrid orbital is going to allow for greater overlap. And this is going to sustain or increase the energy that we get out when these bonds are made. So we're making more bonds, we're making stronger bonds, and that's our motivation to do this. In the last video, we introduced the first of the hybrid orbitals. So we said that this number of standard orbitals added together equals the number of hybrid orbitals. So the first one we looked at, we put in 4 standard orbitals, and this produced for us 4 hybrid orbitals. So we put in 1 S, 3 of the P's, and we got 4 hybrid orbitals, and the name was Sp3. And here's what we see. Now we're going to look at the other options. So we don't have to put 4 orbitals in. If we only need 3, we can only put 3 in. So here we see that we're putting in 1 of our S orbitals, 2 of our P orbitals. So we put in 1, 2, 3 standard orbitals. And what we're going to get out is 1, 2, 3 of the hybrid orbitals. And again, the naming is not terribly complex. We put in an S, we put in 2 of the P's, so this is called Sp2 hybrid. Note that up here we've got that unhybridized P orbital. That's important for 2 reasons. Number 1, by leaving this P orbital out if we don't need it, that causes our hybrid orbitals to be a little bit lower in energy. So remember, our P orbitals are way up here on the energy level, so if we leave one of those out, the average of these hybrid orbitals is going to be a little bit lower. So it lowers the energy to leave it out. We're also going to see later on in the video series where this unhybridized p orbital will be a opportunity for double or triple bonds to happen. So that's the other important piece. So again, these hybrid orbitals are going to come together in a very familiar fashion. So when we put 3 hybrid orbitals together, we get this Sp2 hybridization, and that's going to be a trigonal planar molecule. The last one, if we only need 2 hybrid orbitals, we can put in 1 of the S's and 1 of the P's, and what we'll spit out on the other side will be just Sp hybridized. So put 2 in, we get 2 out. These guys will line up in a very strategic manner and create a linear molecule. So at this point, you're probably like, Miss Maz, how are you going to test me on this material? That is a lot of crazy things going on. Okay. So what I'm going to ask you guys to do is I'm going to ask you guys to draw a Lewis structure. And then I might say, well, what is the hybridization on that Lewis structure? You can look at this first connection here. So the electron geometry and the hybridization scheme are going to be related. So if the electron geometry is linear, it's Sp. If the electron geometry is trigonal planar, it's Sp2. Electron geometry is tetrahedral, it's Sp3. The other way that we can do this is we can use a little saying. So I'm going to try to draw this molecule. So we have a little saying as we're looking at a molecule. So if I hone in on the central atom, the saying goes like this. As I come into contact with something that's connected to that central atom, I would say Sp2, 3. So what would the hybridization on this atom be? It would be Sp3 hybridized. Okay. So as you guys are doing your Lewis structures, once you get to the end, you focus in on your central atom and you say Sp2, 3. If it's something that has just 3 things attached, so again, I'm going to focus in on this carbon central atom. On this one, I would just say Sp2. So one's Sp2 hybridized. Okay. I hope you guys found this helpful.